Hello, welcome. This is the final exam review for Algebra 2. This is going to be part A2. And basically, here on problem number 1, we're asked to write each exponential equation in logarithmic form. And basically, you start with 3 raised to the 7th power equals 2,187. In order to change that to logarithmic, basically, you write log, you write the base is the big number right here, and then followed by the answer. The answer is 2187 equals the exponent. So base, answer, exponent. So as you can see here, I wrote log of base 12, the answer is 144, equals the exponent 2. On the next one, I have a log of base 5, the answer is 625, equals the exponent y. The next one would be log of base w log of base w, the answer is m, equals the exponent z. And the last one, log of base b of the answer is 15, equals the exponent 2. Okay, so basically on the final exam I'm going to ask a question similar to this, and it's going to be multiple choice. Question number 2. Write each logarithmic equation in exponential form. Basically, I have here a logarithmic equation. Remember, this is your base, this is the answer, this is the exponent. So if I'm going to change this to exponential, I write the base, the exponent is the little number, equals the answer. So base, exponent, answer. Base, exponent, answer. So if you get used to the position of the base is the big number, the answer is what is equal to, and this number here would be your exponent. So base, exponent, answer. Base, exponent, answer. And last one is the base b raised to exponent 11 equals 3. Again, just like problem number 1, there will be a question like problem number 2, okay, where I'm going to give you a logarithmic equation and ask you to write in exponential form. Alright, problem number 3. Basically here, you trying to write this logarithmic expression as a single log. In order to do that, you have to use some of the properties that we talked about in class that you can use in logarithmic. Okay, when we're using logs, okay, first thing, the number in front of the log can be moved back inside the log. So you can send this number 3 back inside the log, and when you send it back inside, it becomes the exponent. So here I put parentheses, 2x raised to the third. The reason why I got this 3 here is because I sent that 3 in the front, back inside, it became the exponent. So as you can see, you have number 4 that came in back inside and becomes the exponent. And so it did here. Okay, so the number in front goes back inside and becomes the exponent. Now, 2 to the 3rd power is 8, x to the 3rd power is x to the 3rd. And same thing here, 3 to the 4th is 81, x to the 4th. 6 to the 2nd becomes 36, x to the 2nd. Now that I don't have any numbers in front of the logs, let's combine these logs using some of the other properties that we know. One of the properties that we know is if we have 2 logs of the same base, these are base 5 logs, and you are adding, you can rewrite this as one log, so log of base 5, and what do you do with these numbers? You multiply. So that's what I did here, 8x cubed times 81x to the 4th. So now instead of having 3 logs, now I only have 2. My goal is to write as one log. So what do? I rewrite these two logs. They have the same base, and when you subtract two logs of the same base, you turn into division. So if you notice, I took this guy right here and I changed the minus to division. So I took the 36 and put underneath the fraction. So now I punch it in the calculator. 8 times 81 divided by 36 give me an 18. And then I use the law of exponents. X to the third times x to the fourth. I would add these two exponents, which would give me 7. So x to the seventh divided by x squared. So x to the seventh divided by x squared becomes x to the fifth. So that's how I was able to rewrite these three terms into one log in this problem. Okay, and as you can see on the next three problems, part A, B, and C, I applied the same properties in each one of these problems. There will be one question on the final exam similar to this. The only difference is I'm not going to include numbers in front of the x. Okay, so it will be much simpler. So basically, this would be, if this was the final exam, you're probably going to see 4 log to the base 3 of x, log of base 3 of x, minus 2 times log of base 3 of x. So it's going to be a little bit simpler, okay? But it's the same strategy. If you see plus, that means multiply. If you see minus, that means divide. Okay, another way to look at it is, if it's plus, the number stays on top, and if it's minus, it goes to the bottom because it's dividing. Okay, so please give it a try on these problems, and remember, there's going to be one multiple choice question similar to this. Okay, the next one, we're going to use a calculator. Okay, but before we use a calculator, we need to set it up so we're ready to enter it on the calculator. So for example, here I have log of base 5 of 3. So first of all, I need to write as a fraction. So how do I do that? I write log of 3 divided by log of 5. Once I have that, I go to my calculator and I click log of 3, close parentheses, very important to close the parentheses, divided by the log of 5. And close parentheses, enter. My answer then is 0.682. So the problem asked me to round to the nearest thousand, so I rounded to 0.683. Okay, so let's give it a try again here. First I change to a fraction, and then just press log of 9, close parentheses, divided by the log of 5. Press enter, and that's my answer, 1.365. And so on. So the following problems will be just the same steps. You know, write as a fraction, and then just enter in the calculator. Log of 17, close parentheses, divided by the log of 5, close parentheses, press enter. And remember to round to the nearest thousands. I forgot to write the little 7 right here, so if you please make that correction. Okay. Alright, problems 5 and 6, I'm not going to go into detail because I decided not to include these problems on the final. So we're going to save time and I'm going to skip this. You still are supposed to do the final exam review and turn it in, but I'm not going to spend time going over because we have many more problems to go over. Okay, so problem 5 and 6, they're good review. We covered in class, but we're not going to include on the final due to time constraints. Okay, now that moves us to problem number 7. Okay, problem number 7 is asking you to find the inverse. Okay, there will be a question similar to this on the final exam. It's going to be multiple choice, and basically it gives you a function like 3x over 5 minus 2, and as always, remember the f of x is the same as y. So I always like to write change the f of x to y to remind me that this is your y. And to do inverses, we're going to switch the y with the x. So if you notice, I just switched, the x took place of y and the y took place of the x. Now all we have to do is get that y by itself. So how do I do this? I move the 2 to the other side. Okay, so that leaves me 3y over 5 equals x plus 2. I need to get rid of this fraction, so what do? I put parentheses on both sides and I multiply by 5. The 5 on this side cancel. I'm left with 3y. And on this side, I use distributive property. 5 times x is 5x. 5 times 2 is 10. How do I get the y alone? Divide both sides by 3. So I'm left with 5x plus 10 over 3. And my final answer there, I change back from y notation to the formal notation or function notation. In this case, the inverse of f of x equals 5x plus 10 over 3. Okay, and as you can see, here's 2 more problems where you can practice same steps. Okay, please be careful. Very common mistakes is students move this 5 to the other side and they forget to change the sign. That was something that occurred a lot on the test that I noticed. So please be careful. If you move one number to the next side, please remember to change your sign. Okay, very well. So there will be one question like this. Okay, also here we have f of x equals a logarithmic function. Okay, same steps, change f of x to y, then do the switch. X takes place of y, y takes place of x. Now our job is to get the y alone. So how do I do that? Well, we're going to bring the base on both sides. Okay, so if you notice, I'm bringing base 5 on both sides. And by bringing base 5, the 5 cancels the log on this side. You're left with 2y squared minus 3. And on this side, I have 5 raised to the x. So how do I get the y alone? I'm going to move the 3 to the other side. 2y squared. How do I get that alone? I divide both sides by 2. And the 2 cancels, left with y squared. How do I get rid of the y squared? I take the square root of both sides, remembering to put positive and negative. And then I just write in function notation. Positive, negative, square root of 5x, 5 to the x plus 3 over 2. Okay, here's 2 more problems where it follows the same pattern. Okay, alright, so basically change the x with the y. How do I get rid of a logarithmic function? Introduce the base. The base here is base 3, so that means I'm going to bring in a base 3. That means big 3's. And these guys becomes my exponents. The 3 cancels with the log. Okay, and you left with 3 to the x equals 7y squared plus 5. The rest is just getting the y alone. Move the 5 to the other side, divided by 7. Once the y squared is alone, how to get rid of the square? Square root of both sides, remembering to put positive and negative, and that's your answer. So here's another example. Okay, alright, the next one is going to be, here's an exponential function and find the inverse of that. So first of all, change the f of x to y, switch the x with the y, so same steps. Okay, now that I have this, how do I get rid of exponential? Bring in the log on both sides of the same base. So if this is base 14, so we're going to bring log of base 14 on both sides of the equation. So this would be the log of base 14 of 14 raised to the 2y plus 3. What happens here? The logs cancel. We're left with log of base 14 of x equals 2y plus 3. I'm going to move the 3 to the other side. We got 2y equals that. How do I get the y alone? Divide both sides by 2. That's your inverse. Okay, here's 2 more examples. If you notice, switch the x with the y, bring in your log of the same base that you have. You have base 11, I'm going to bring the log of base 11. Here I have base 5, so what I'm going to do, bring log of base 5. Alright, the log of base 5 cancels the base 5, okay, and that will be your answer there. Okay, so this concludes part A2. Okay, basically there will be a question like this, one on inverses with a fraction like this, one question with log, one with exponential. Okay, so each one of these is going to be multiple choice, so please look this over to prepare yourself for the test. Okay, so this finished this session of the final exam review. I hope that it was helpful, and thank you very much for your time, and have a great day.